Hello. Today we will discuss the intensity distribution of interference. So let's get started. Now this is a screen. At any point on the screen is P, and S1 and S2 is the two coherent source, and they produce a coherent light beam to form interference in the screen. So this is a S1, very small slit it is, these are, and S2 is another coherent source. So they produce a light and the light rays emerge at point P. Now the disturbance at P due to S1, it is Y1 is equal to A1 e to the power j omega t minus kx1. What is kx1? Where this phase difference of these two wave, this is 2 pi by lambda x1. What is x1? x1 is a s1p. So we can write 2 pi by lambda s1p, and this is k and x1. Okay, so the next step is the disturbance at P due to S2, and this is y2 is equal to A1 e to the power j omega t minus kx2. Okay, now by principle of superposition we can write by principle of superposition we can write y is equal to y1 plus y2, that is A1 e to the power j omega t minus kx1 and plus A2 e to the power j omega t minus kx2. Okay, just open the bracket. E1 a j omega t into e kx1 plus A2 e j omega t into e minus kx2. This take common e to the power j omega t, and we get A1 e to the power minus kx1 plus A2 e to the power minus kx2. Okay, so this can write e to the power j omega t as it is, and it is cos kx1 minus I sin kx1 plus A2 cos kx2 minus I sin kx2. Okay, now in the next step we open the bracket and separate the cos term and sin term within a bracket. So e to the power j omega t and A1 cos kx1 minus A1 I sin kx1 plus A2 cos kx2 minus A2 I sin kx2. Okay, now e to the power j omega t, and this is the cos term and this is the cos term, so we can write A1 cos kx1 plus A2 cos kx2. Okay, and this is a sin term and this is a sin term, so we can write minus, take minus common and I common, and this is A1 sin kx1 minus a2 sin kx2. Okay, now let this is a and this is b, so we can write e to the power j omega t, and it is a minus ib. Okay, this is a complex number, and from this we can write the amplitude of this complex number e to the power j omega t root over a square plus b square, and e to the power j phi, where phi is the phase difference and where phi is equal to tan inverse b by a. From complex number, this we get this phi is equal to tan inverse b by a. So the next step we can write the it is root over a square plus b square e to the power j omega t minus phi. It is j phi and j phi common, and omega t minus phi. So from this we can write, now we let a is equal to, where a is equal to a1 cos kx1 plus a2 cos kx2, and b is equal to a1 sin kx1 plus a2 sin kx2. Okay, and from this step we can write y is equal to y1 plus y2, and it is root over a square plus b square and e j omega t minus phi. So this is the amplitude part of the superposed wave. So this is a, and a j omega t minus phi. So where a is equal to root over a square plus b square. Okay, and we find the intensity of the interference pattern. So to find the interference pattern, we find the a square. The a square is a root over a square plus b square, then a square is equal to a square plus b square. Now put the value of a and b. Now a1 cos kx1 plus a2 cos kx2 and this whole square plus b a1 sin kx1 plus a2 sin kx2 and then whole square. So just open the bracket, a1 square cos kx1 plus 2a1 a2 and 2a1 a2 cos kx1 cos kx2 plus a2 square cos square kx2 plus a1 square sin square kx1 plus 2a1 a2 sin kx1 sin kx2 plus a2 square sin square kx2 square. Okay, now this is cos part, and this. Now now we separate the A1 part and the A2 part. Okay, so A1 square cos square kx1, and A1 part is this, plus A1 square sin square kx1. This is A1 part, and A2 part is this, so A2 square cos kx2 plus A2 square sin square kx2. Okay, and write this part off. So take 2A1 A2 common, and let is, okay, is the next line, 2A1 A2 common, and it is cos kx1 cos kx2 minus plus cos sin kx1 and sin kx2. Okay, so I proceed the next step. So next step is that so next step is take common A1 and take common A1 square, so we get cos square kx1 plus sin square kx1, and take common A2 square, and we get take common A2 square, that is also cos square kx2 plus sin square kx2. Okay, and this is a formula. This is a formula, so we can write from this A1 A2 is cos k x1 minus x2, sorry, x2 minus x1. This is a formula, and next line this is equal, and next line this is a 1, cos square theta plus sin square theta is equal to 1, so A1 square plus this is also 1, and A2 square plus 2A1 A2, and this we let cos del, where del is equal to k x2 minus x1. Okay, this we have, and the intensity is given by the intensity always proportional to the square of the amplitude part of superposed wave. Okay, so we can write, so intensity is given by I proportional to a square. Okay, and a square is this A1 square plus A2 square plus 2A1 A2 cos del. So intensity is A1 square plus A2 square plus 2A1 A2 cos del, where del is k into x2 minus x1. Where what is x2 minus x1? x2 minus x1 is the path difference of two coherent beam. Okay, sorry, not coherent beam, it is two path difference of two waves. Okay, so from this we can